Hey, so in this lecture, we are going to look into what is data partitioning in key value store. So let's now look into the first building block of our key value store, which is our data partition. So this thing which we have introduced earlier also. So what is this thing is like if we have a huge amount of data size, and since this huge data size cannot be stored into single server, what we do is split the data into smaller partitions, and store this data into multiple servers. So while doing this, we have to keep certain things in mind. Consider a scenario like I have this key 1, key 2, key 3, like key 10. And I have say multiple servers like server 1, server 2, server 3. So if suppose key 1 to key 8 is being mapped to S1. So S1 currently stores key 1 to key 8 and S2 stores key 9, S3 stores key 10. Even if any case this server 1 is down, then all these keys are lost for the time being. So if we do a read request for a particular key, we return a stale data, either a stale data or we return no data. All these keys have to be mapped to server 2 or server 3. There will be a latency, there will be a poor performance of this architecture. So first thing which we need to keep in mind is data should be distributed evenly. This is one. And even if the data is being distributed evenly, suppose I distribute the data, I also take care K1 to K4 is here, K5 to K7 is here, and remaining K8 to K10 is here. And even if this data is down, or the server 1 is down, data is unavailable for the time being, we have to minimize this data movement. So you'll eventually see that if we handle this scenario is also being handled automatically by the logic which we implement to handle these scenarios. But these two things need to be kept in mind. Minimize the data movement whenever a server down or another server is up due to influx a huge amount of key value pair. So to achieve these two things and to avoid all these scenarios, we introduce a new thing called, or a new topic called consistent hashing. So this is itself another topic which we can have a deep dive into it. If you want, I can make a video on this. Let me know in the comments. But for the time being, I'll give a high-level view of what is this thing and how it works. So it basically works on the basis of SHA algorithm, hashing algorithm. So it hashes the keys into some certain hash values. It has a hash ring attached to it, and the servers are distributed in a circular manner on it. Suppose I have 4 servers, and depending on the hash values, they are mapped on the ring. Like let's say key 1 is here, key 2 is here, key 3 is here, and key 4 is mapped here. And we move in a clockwise direction, and the first server which a particular key encounters, that key is being assigned to that particular server. So if we move in a clockwise direction, K2 is assigned here, K1 is assigned here, K3 is assigned to S2, and K4 is assigned to S3. So in this way, the keys are being assigned to the servers. So now I will write something 1 by nth percentage of number of key value pairs. Can you guys think what is this? What is this figure? What does it denote? Pause down the video. Just think about it. What does it denote? Why did I write this? It has to be something related to this and related to this also. And if you can guess it, just write it in the comments given the timestamp. Or else I'll say what is this. So earlier I mentioned like we have to minimize the data movement. Whenever we introduce this consistent hashing or a hash string, you can see the data is being kind of evenly distributed, and the amount of data which we can move whenever suppose this server 1 is down or we introduce another server due to a huge influx of key value pairs, this data, the amount of data which we move, is always boils down to 1 by nth percentage of key value pairs. What is 1 by n? Though n represents the number of servers. This is basically if you particular maths, simple maths. So if you see I have 4 servers, I distribute them into n partitions, and the total number of keys, 1 by nth of those keys, will be moved if any server is down or if any server is added. So using this architecture, using this consistent hashing, we can achieve 2 things. One is automatic scaling. What is automatic scaling? We can easily add or remove a particular node depending on its condition or depending on the amount of data which is being influxed into the server nodes. Add or remove server nodes automatically. Another situation which might arise, if you can think about it, let's say suppose I have this ring and my hashing algorithm maps the keys, or keys are such that the hashing algorithm maps the keys all here, K1, K2, K3, K4, and we are now boiled down to square one from where we started. We wanted evenly distributed data, minimized data movement, but all these keys are now being mapped into S1. So what we do is here is we introduce something called virtual server nodes. So virtual server nodes are basically part of the actual servers, but they are numbered like S1, 1, you number S1, 2, here suppose S0, 1, here suppose S2, 1, and suppose here also we have this S0, 1. Once we introduce this virtual server nodes, these keys now map to their nearest server nodes and not to the particular server which they were currently mapping. By this, we again achieve what we wanted to and what we had to keep in mind, like the data movement should be minimal and the data should be evenly distributed. So the virtual server nodes, the number of virtual server nodes should be proportional to the server capacity or server size. So what does it mean? Is like suppose this S1 can store up to hash values from 100 to 500. S2 can store from say 501 to 600. Let's say S3 can store from 601 to 650. These are hypothetical numbers. And S0 can store from 650 to 700. So as you can see, S1 can store 400 hash values or key value pairs, whereas this can store only 100. So the number of virtual server nodes for S1 would be higher than the number of virtual server nodes of S2. So this thing is called heterogeneity. So these are certain terms which you need to remember, but just understand the concept behind this and you will eventually get it what are this. So you can think of these things without memorizing, like what is the problem, what are the worst case, what are the situations which might arise, and eventually you will get the answer of these things and you will eventually learn these terms. So now we have achieved this data partitioning. The data should be evenly distributed. There should be minimized amount of data. For this, we use a consistent hashing. So this consistent hashing uses a hash ring, distributes the data evenly among the servers. Even if a server is down or even if we add a server, the data movement is minimal. And this value is 1 by nth percentage of key value pairs. We can achieve automatic scaling using this consistent hashing, using the hash ring, and the virtual server node concept, which handles the case whenever a large number of keys are mapped to a single server. So now we will look into the second building block, which is our data replication. If you remember the 8 building blocks which we have to build a key value pair. So now let's look into what is data replication.